All right, this is the Lesson Master Videos 3.1 to 3.6, just to help you in case I didn't get questions answered in class. Okay, number one, it wants to know what's the equation for an asymptote of f. So I have an asymptote of y equals 3, and I'm supposed to apply this translation rule. So all I'm going to do is take my y and I'm plugging it in here, so that means I just get y is equal to 6. The line of symmetry is equal to x equals -2, so again I'm going to apply this rule and I get a line of symmetry to be x is -4. So all I'm doing is taking that translation rule and applying it to both the asymptote and the line of symmetry. Okay, 2a wants me to give equations for the asymptotes of its graph and describe any lines or points of symmetry. So first thing I'm going to do is look at this equation as y minus 6 equals 1 over x plus 1/2 squared. This parent function is y equals x squared. Let's try 1 over x squared, and the two asymptotes related to that are x is 0 and y is 0. So I'm going to go figure out what's the translation rule going on in here first. So again, I have a translation. I know that because it's a plus, but remember in here it would be a minus 1/2, and in here it would be a y plus 6. So the new equations, there's my old. I'm going to apply that translation rule. I get x is -1/2 and y is equal to 6. All right, if you think about the parent function for the inverse square, it looks something like the following. And it doesn't have a point symmetry, but it has a line symmetry right here, which is x is 0. So again, I'm going to apply this rule, and we end up with x is equal to -1/2. I would not stress over that section. That really was not the main emphasis. The main emphasis on this section really is when we get to objective E. Determine whether it is even, odd, or neither. Justify it algebraically. So when I go and do this, I'm looking at f of -x. So I'm taking -x, I'm plugging it in for that t, and this ends up giving me 7x to the 8. So because these are the same, again, that means this is even. If I was to make a quick sketch just to verify, this one ends up being a quadratic, which again is line symmetry, which just reinforces the fact that algebraically I know that it was even as well. Next one again, I'm going to take -x and plug it in. Raise that to the 7th, raise it to the 2nd. So here I have a negative raised to an odd power, so that means I'm going to have -5x to the 7th. Over here that ends up being positive x squared times that -3. Now remember, to be odd, this has to be the opposite of this function, and it's only the opposite of the first term. So in this case, this one is neither. And again, if you went and looked at the graph, it shouldn't have line symmetry through the x-axis, or, y-axis, or point symmetry either. Let's take a look at the last one. So -x to the 2nd is x squared plus 3. And again, these are the same, which makes me think it's even. And if I had to sketch this out, it would look something like the following, and again, that is symmetric with respect to the y-axis. Okay, moving on to the next set, I have to figure out which ones are even or odd or neither. So remember, if it's even, that means it has to be symmetric with respect to the y-axis, which is neither one of these. If it's odd, that means I should have point symmetry about this point right here, which I do. So number 6 is odd, and number 7 is odd as well. And watch what I'm doing. I can again take my paper, I can flip it upside down, and notice those graphs are oriented the exact same way. 8, it wants us to describe symmetry. This one right here looks like it has point symmetry about the origin. And this one actually has line symmetry, and it's over here, which is x equals approximately -2. I'm going to point out one other thing that we had talked about in class. If it is, in this case, odd, then the transformation, let's take a point on this graph right here. Let's suppose this point right here is -1, 1. The transformation for an odd is x comma y, gives you -x comma -y. So let's see, is x comma y is this point? When I take the opposite of both of those, I end up with 1, -1 is that point on the graph, and again, roughly it is. So that's another way of knowing that it's an odd function. Okay, moving on to lesson 3.5. Find the image. So I think what they're asking us for is actually to write the rule. So I have a shrink horizontally by 1/3, so that would be a 1/3 x, and stretches vertically by factor of 5, so that would be 5y. Remember, if it's vertical, it affects your y. If it's horizontal, it affects your x. The next one, we have to find an equation under the following. So remember, I'm replacing y with the inverse operation, which is y over 3. Over here, I'm replacing x squared with, again, the opposite of that would be 2x squared. You can leave it in this form, or if we wanted, we can simplify a little bit. That would be y over 3 equals 4x squared plus 1. Finally, if I wanted to multiply through by 3, I can do that. Okay, number 3, I have to describe 2 different transformations. So this first one is noticed based on my x, which means this is the horizontal translation, or excuse me, scale change. Nothing is going on with my y's. I'm going to rewrite this 9/4 as 3/2 to the second. So instead of multiplying by 3/2, they are dividing by 3/2, which is the same thing as multiplying by 2/3. Okay, to get the vertical change, I'm going to rewrite this so I have x squared by itself. We get x squared equals 4/9 y. In this case, nothing is going on with my x's. Again, my y's aren't being multiplied by 4/9, but they are multiplied by 9/4. Okay, number 4, if y is replaced with 3y. So that means in the equation I'm replacing it with 3y, but what's actually going on is I have a shrink, and it's vertically since it's affecting the y's. Okay, the next one, I have x-intercepts of -2, 0, and 1, and a y-intercept of -4, and I'm going to apply the following. Remember, the rule tells the truth. So these are x values, which means I'm going to take each one of those and multiply it by 3. So my new x-intercepts are -6, 0, and 3. The new y-intercepts, I'm applying the y rule, which in this case is multiplied by 2. Number 6, what effect does this transformation have on the graph's asymptotes?